All right, today we're diving into a technology that seriously sounds like it was pulled straight out of a sci-fi movie, but it could completely reshape our world. It's called Flash Joule Heating, and it has this wild promise of turning our biggest, nastiest waste problems into some of our most valuable resources. So let's get right into it.
So let's just start with a huge question. What if we could take our most problematic waste? Things like toxic chemicals, old batteries, even that nasty sludge from oil refineries, and in a literal flash, transform it all into some of the most advanced materials on the planet? Yeah, it sounds a lot like alchemy, right? But that is the core promise of the tech we're exploring today. So, how does this magic trick actually work? Well, in this first section, we're going to break down the fundamental science. And don't worry, the concept is brilliantly simple, but the practice, well, that's absolutely revolutionary.
Okay, so at its heart is something called Flash Joule Heating, or FJH for short. I want you to imagine taking a material and just hitting it with a controlled, microscopic lightning strike. This jolt of electricity is so incredibly intense that it heats the material to over 3,000 Kelvin, that is hotter than the surface of some stars, and it does it in just a few milliseconds. This extreme, rapid-fire heating completely rearranges a material's atoms before they even know what hit them.
The process itself is surprisingly straightforward. First, you take your starting material, the precursor, which by the way can be anything from coal dust to plastic waste. You put it in a reactor. Second, you zap it with that massive electric pulse. Third, the temperature just goes through the roof, almost instantly. And fourth, as it rapidly cools down, the atoms are basically frozen into a completely new, highly ordered, and often incredibly valuable structure, like the supermaterial graphene. It's a four-step recipe for turning trash into treasure. Now, as you can probably imagine, a tool this powerful has gotten a lot of attention. Scientists aren't just using FJH anymore. They're constantly upgrading it, turning what was a blunt instrument into a precision scalpel for material science. Let's see how they're making this thing even more powerful.
And what's really fascinating here is just how much the hardware has evolved. You see, the first FJS systems were these expensive, super complicated lab setups, but recent breakthroughs have totally changed the game. Get this, researchers have figured out how to use common components like off-the-shelf arc welders to build low-cost, scalable reactors that are capable of producing kilograms of advanced materials every single day. That's the leap from a lab curiosity to a potential industrial powerhouse.
And the level of control they have now is just getting better and better. This isn't just a brute force zap anymore. No way. Scientists can now act like master chefs, precisely tuning every little variable. They can tweak the voltage to control the quality of the crystals, add catalysts to guide the reaction towards a specific material, and even apply magnetic fields to influence the final structure. It is a level of precision that allows them to create custom-designed materials pretty much on demand.
So with this upgraded high-precision toolbox, what exactly are we building? This is where it gets really, really exciting. Because with this level of control, scientists are no longer just discovering materials, they're actually designing them from the ground up. So let's take a look at just a few of the groundbreaking materials being forged in the Flash.
First up, we have something called amorphous metallic glass. Okay, think of it like this. Most metals have a really neat, orderly, crystalline structure, right? Like bricks stacked in a perfect wall. But FJS's unbelievably rapid cooling process freezes the atoms in a jumbled, disorganized state, like glass, before they even have a chance to line up. It's like flash freezing all those bricks in midair just as the wall is tumbling down.
And this is exactly why FJH is such a huge deal. This unique, chaotic structure isn't just a curiosity. It unlocks entirely new properties. These metallic glasses are incredibly stable, and they show amazing performance as catalysts. Those are the materials that speed up chemical reactions for things like clean energy production. We're talking about a whole new class of high-performance metals that you just couldn't make with the old, slower methods.
Next, let's talk about carbides. Now, these are compounds of carbon and metal, and they're known for being incredibly hard and super heat resistant. With FJH, scientists can now engineer the exact phase or the structural form of these materials with absolute pinpoint accuracy.
This level of control is absolutely crucial because it allows us to build materials for the most extreme jobs out there. We can create pure forms of molybdenum carbide, which is amazing for producing clean hydrogen. Or we can make these durable hybrid structures of tungsten carbide that can withstand brutal industrial conditions for days on end without breaking down. These are the super materials that we need for the next generation of industry.
Okay, so creating exotic new materials is fantastic, but how does this technology help us solve problems right here, right now? This is where FJ pivots from being a scientific marvel to being a legitimate world-changing solution.
Let's start with a really big one: toxic waste. When scientists applied FJH to carbon that was contaminated with PFAS, those infamous forever chemicals, it destroyed more than 96% of them. It converted the hazardous pollutants into harmless fluoride salts. It doesn't just contain the problem, it actually eliminates it. And what about our massive e-waste problem? Well, when they used FJH on the black mass from old lithium-ion batteries, it accelerated the metal recovery process by about 1,000 times. This makes recycling batteries faster, cheaper, and way more efficient, tackling a huge environmental challenge head-on.
And hey, remember those scalable new reactors we talked about? They can take waste products like carbon black or even refinery sludge and churn out high-value graphene at a rate of 3 kilograms per hour. We're talking about turning a constant stream of industrial waste into a constant stream of a supermaterial. It's incredible.
And look, don't just take my word for it. A full life cycle and economic analysis by researchers Saudi and their colleagues confirmed it. When you're upcycling refinery waste, FJH has, and I quote, significant environmental and cost advantages over the old ways of doing things. It's cleaner and it's cheaper, and that is the combination that drives real-world change.
All right, so we've seen the science, we've seen the materials, and we've seen the real-world impact. So where does this incredible technology go from here? Let's wrap things up by looking at the future that FJH is busy forging for us. The big takeaway here is this: Flash Joule Heating isn't just a small improvement, it's a total paradigm shift. It represents a move towards a future where we can create the exact materials we need right when we need them, using our own waste as the raw ingredient. It's a truly circular and sustainable approach to how we make things.
And that leaves us with one final, tantalizing question. We've already seen metallic glass, custom carbides, and upcycled graphene. So as this technology gets even more powerful and more precise, what other currently impossible materials are we going to start making with the power of a lightning strike in a box? The possibilities, honestly, are just dazzling.